Hello, everybody. So to introduce this last assignment on isochrons, I'm giving you a new set of data. So here, this is titled TIC, rubidium, strontium, and samarium, neodymium. Now, in the earlier exercise, we used the calculated rubidium 8786 values. Here, these are measured values. So I want you to compare the age dates you get from the previous assignment to the ones we get by looking at measured 8786. There are a number of units here. What I simply want you to do is create a table, and the table will have a unit name like Cathedral Peak, and then you can say calculated 87 rubidium, 86 strontium, and that could be versus measured rubidium, 87 strontium 86. This would be an age, and this would be an age. So go ahead and calculate the ages using these data and put that over here on the measured side. And then from the other assignment, put in the calculated age that you got before. The second part of this is going to be the same kind of an assignment as the earlier one, but I want you to create a samarium neodymium isochron. Now, I'll tell you ahead of time, these probably aren't going to turn out very well. I've done these myself, and for some reason, they always come out a little bit weird, and I think it's because the half-life is so long. So here, for rubidium strontium, I have the half-life in billions of years, total years, and here's the decay constant. And the half-life is about 49.5 billion years. But it's more than double that for neodymium. And I think because these are very low concentration with a very long half-life, that there's just a little bit more error and it's harder to get ages. So you might get some weird ages out of it. But I still want you to just kind of treat all these together. Just treat them as one unit. We don't really have enough. Well, I guess you could do a two-point line for the Cathedral Peak. But go ahead and take a look at getting an age out of these units and just see what you get and report it. And don't be too worried if it's some crazy number. But do try, of course, to do it correctly. And then compare that to the ages that you get from the rubidium strontium isochron numbers. So that's it for correcting the isochrons. And then we'll come back later and compare neodymium and strontium isotope ratios in a mixing.